Friends, in this session we will be introduced to a whole new world, a world of physics. In this beautiful planet that we call Earth, there are a lot of interesting events that take place. These events are around us, which we see or do or experience almost regularly. At some point in time, your curiosity would have definitely got the better of you and would have pushed you to ask questions like, what's going on or how does that happen? Well, leaving miracles apart, the answer to all these questions is physics. You see, there is more to events in our everyday lives than what meets the eye. So, to appreciate the events that you see, you have to first understand events that you don't see. Confused? Don't worry. Let's make it simple by looking into 10 of our everyday life examples at random. We all know what that sound is, don't we? It is a very annoying yet important sound which tells us that we have to be up and about. We wake up in the morning at the sound of the alarm. Sound is something which we can't see but can hear or experience. It is used in important medical equipment like the ultrasound scanner and by ships to estimate the depth of the ocean. Physics studies the origin, propagation and properties of sound. Let's make a note of this event of sound and other events yet to come in the session before we define what physics is in the end. To have a cup of coffee, we boil water. After turning on the stove, we notice that the water is hot enough when it starts boiling and when we see steam. This gradual rise in temperature that causes the water to bubble and later change to steam is called heat. Thus, we get hot water by heating, that is, increasing the temperature of water. Heat is used in the industry to melt metal and make various types of heavy-duty machinery like automobiles and generators. It is also used in household appliances like the electric or steam iron. Heat and its properties is an important topic of physics as well. While we take a walk in the park on a tar road, we have a good grip without slipping because of a sort of roughness or resistance between the soles of our shoes and the surface of the road. This resistance that's responsible for grip is called friction or traction. But say if we're busy on our cell phones or waving at our friends and we do not notice a banana peel in front of us. What makes us fall? Well, apart from our absent-mindedness, it is due to the reduced friction between our shoes and the road because of the slippery banana peel. Friction, which is an important factor in the making of tires, is also explained by physics. We have all observed apples falling from a tree or balloons floating away in air. How is this possible? The apples fall down while the balloons float up? This is nothing to be puzzled about. The answer is simple. Our Earth has a kind of a pull that draws every object to its surface. This pull is called gravity or gravitational force, which keeps every object grounded to the surface of the Earth and prevents them from floating away. This is why apples fall to the ground and why people or objects on the underside of the Earth do not fall into space. So why did the balloon float away and not fall to the ground? Again, it's no big deal. We know the air is light. So imagine something which is lighter than air, like say helium gas, filled into the balloon. Because it is light, it rises to a level higher than air and thus works against gravity, which now cannot keep the balloon grounded. Gravity is studied to a great extent by astronauts to mimic conditions in outer space. In fact, gravity is the very event that was studied by Sir Isaac Newton, who is now considered one of the fathers of physics. When we use a compass, we notice that the direction of the needle is constant. That is, the needle points in only one direction, north. This is because of a force of attraction between two oppositely charged ends called magnetism. All materials that follow magnetism can be termed as magnets. Did you know that apart from being just a planet, our Earth is actually one big giant magnet? The geographic north pole of the Earth, that is the Arctic region, is actually the magnetic south pole, which attracts the magnetic north pole of the compass. This is why the compass always points north, no matter where it is. We all know opposites attract, don't we? Physics looks into the property of magnetism, which is used in modes of transport like the metro trains and in parts of electronic speakers.